Thanks for joining NuttX online workshop. My name is Masayuki Ishikawa from Sony Home Entertainment and Sound Products. Today, I'm going to talk about how to implement a USRSOCK-based Wi-Fi driver on NuttX products. Today, I'm going to talk about how to several technical backgrounds including embedded systems. In the past, I have developed Linux-based and Android-based audio products. For example, this A800 is the first generation of Linux-based media player, so which has ARM9 inside. And ZX1 is the second generation of Android-based media player, which has dual Cortex A9. I started to use NuttX in 2013, and finally we released the first NuttX-based audio product in 2015. This UX560 is the first NuttX-based digital voice recorder. Also, we released several NuttX-based audio products such as SP900. Now, I'm doing feasibility studies for the future audio products based on NuttX. Here is today's agenda. So before talking about software, firstly let me introduce hardware, including Wi-Fi module called TERT GS2200M. Then I'm going to talk about software architecture, including USRSOCK. Then I introduce actual use cases, and finally I will show you demo video. This is the hardware for testing. Spresense is a board name developed by Sony Semiconductor Solution. It has 6-core Cortex M4F running up to 160 MHz, and it has 1.5 MB SRAM. It also supports microSD HCI and SPI. As for Wi-Fi module, we use TERT GS2200 for this study, which support 11BGN. This Wi-Fi module supports 1.8 to 3.3 for I/O voltage, and with Spresense, I/O voltage is set to 1.8. As for interface, it supports UART, SPI, SDIO, but in this study, SPI is used. Also, the module has embedded TCP/IP stack inside the module. This just shows pin assignments for Spresense. As I explained, Spresense provides 1.8 for I/O voltage. Also, you can see reset pins assigned to UART to RTS on Spresense. This means that we have to change UART RTS pin to GPIO. In addition, IRQ pin, which is assigned to GPIO 37 on GS2200M, is connected to UART to CTS pin on Spresense. So this pin also must be changed to GPIO. So finally, SPI 5 must be configured to use. You can also use STM32 Discovery board with GS2200M. This board has single Cortex M4F, and SRAM size is 128 KB, so which is very small compared to Spresense. As for microSD, I use microSD over SPI for this study, but you can use SDHCI as well if you change hardware and software configurations. These are pin assignments for STM32 board. With Spresense, BDD-IO was 1.8. However, I decided to use 3.3 for BDD-IO because this Wi-Fi module supports 3.3, and I don't care about the power consumption with this board. If you are interested in these configurations, please check the latest upstream code. From here, I'm going to explain protocols between host processor and the Wi-Fi module. This is a so-called HI frame format on SPI from MCU, microcontroller unit. Actually, I don't know what HI stands for, but I guess HI means host interface. When sending data from processor to the Wi-Fi module, so we need to use this frame. In this frame format, there is a class field which shows request type, such as write request, read request, and data. So when sending a request, you have to set this field as well as length and checksum field. This is another frame format on SPI, which is used to response frame. In class field of response frame, you can see several response codes, such as write response OK. However, you can also see write response NOK. This value means that previous request was not processed on the Wi-Fi module. Perhaps the module was busy. Actually, we can see this response code when running several network applications and they generate heavy network traffics. In this case, Wi-Fi driver on NuttX will retry to transmit of the frame. This just shows write transaction. So when sending data, so firstly, the driver checks if GPIO 37 is low. So which means that there is no interrupt from Wi-Fi module. And if it's okay to start a new transaction, then write request, send write request, and wait for GPIO 37 too high, which means that data is available from Wi-Fi module. And if GPIO 37 is set to high, then receive write response, which means OK to send. Then send data header and actual data. Next just shows read transaction. This transaction starts when GPIO 37 is set to high. In the driver, rebel trigger interrupt is used to handle this interrupt. If GPIO is set to high, then the driver sends read request and wait for GPIO 37 is set to high. And if GPIO is set to high, then receive read response. And after that, it receives the data header and actual data. This just shows software architecture. On presence, the latest NuttX, that is 9.1.0 now, and some applications, for example, Telnet and web service are running. Here, yellow boxes are newly implemented for this study. They are Wi-Fi daemon and Wi-Fi driver. And center of this chart, you can find threaded USRSOCK driver. So when network applications such as web server calls a socket API, callback functions such as socket request, close request on GS2200M daemon are called via threaded USRSOCK driver. So, what is USRSOCK? The answer is that it's a user space networking stack API. Also, it's a user space daemon and how provide the NuttX networking features. This allows seamless integration of hardware-provided TCP/IP stack to NuttX. As I said earlier, Tate Wi-Fi module has an embedded TCP/IP stack inside the module, so we do not use TCP/IP stack on NuttX. Instead, we have to use this USRSOCK to access TCP/IP stack inside the module. In GS2200M module, there is a software so-called serial to Wi-Fi. This provides Wi-Fi capability through a serial interface. This approach offers double-run TCP/IP stack to the Wi-Fi chip, and host processor can use serial commands to create network connections. These are 80 commands examples. For example, to stop internal DHCP client on the Wi-Fi module, we can send a 80 plus DHCP command. Also, to connect to our Wi-Fi access point, we can use 80 plus WA command with SSID. These are another command example to create TCP and UDP sockets. For example, if we want to create a TCP client socket, you need to send 80 plus NC TCP with destination address and port. Also, if we want to create TCP server socket, you need to send 80 plus NS TCP with port. From here, I'm going to talk about actual sequence. Firstly, initialize GS2200M driver and connect to Wi-Fi access point. Then run DHCP client to send DHCP packet, which is a UDP packet. We need to use bulk mode and CID, so which I will talk later. Also, to receive a DHCP reply packet, interrupt and work queue on NuttX must be used. After IP address is assigned, run wget command, so which uses HTTP over TCP. In this sequence, we also need to use bulk mode and handle the TCP flow control in the driver. And finally run telnet daemon. This slide shows a driver initialization sequence. In NuttX, there are several initialization routines. A board-specific initialization, so which is board GS2200M initialize, is called via board app initialize. In this function, do board-specific settings such as GPIO and SPI. This called GS2200M register, which registers a GS2200M driver. In this function, set SPI mode, reset and reset the module, and attach IRQ handler. After IRQ is attached, GS2200M start is called. In this function, check boot message from GS2200M. Then send command to disable echo and activate RX circuit, and finally enable interrupts. Next is to connect to Wi-Fi network. In this step, we need to send several commands. For example, to set to in station mode, send 80 plus WM equals 0 command to the module. Then disable the internal DHCP client so that we can use DHCP client on NuttX instead. Then set local IP address with LT plus and set command. Then check the MAC address. And finally, join the network with 80 plus WM command. To run DHCP client, you can use renew command on NuttX. And to see the IP address, you can use ifconfig command. Actually, it will take a few seconds to obtain IP address. But you can see an IP address has been assigned like this screenshot. This slide shows more detailed sequence on its system call. So firstly, when this HTTP client calls socket system calls, then socket request in GS2200M daemon is called to allocate USRSOCK ID, so which is used inside USRSOCK, but no driver call happens. In I/O control system call is simple. This code is used to get and set interface info. Send to system code is not complicated but tricky. It only provides connection-oriented client API, so I had to use a UDP server to allocate CID. Receive from system call is a little complicated because it needs to handle interrupt handler and kick the work queue so that it can receive the a new packet in the work queue handler and notify user. In the user land, receive from request handler is called to copy data from the driver, and finally, receive from system call is unblocked. Close system call is very simple. It just calls I/O control to send 80 plus and close to deallocate CID. So here I need to explain more about CID, so which is connection identifier. So CID stands for connection ID, so which is used in GS2200M to distinguish a network connection. It supports up to 16 connections and represented in hexadecimal number. So we need to manage this CID in the driver as well as USRSOCK ID, so which is used for USRSOCK driver. To send and receive UDP packet, we have to use bulk mode in GS2200M. In bulk mode, a packet data must start with escape sequence press character Y, so which means it's a UDP bulk packet. Also, CID, IP address, port, data length, and data must be specified. As I explained earlier, there is an interrupt handler in the driver. In the handler, just disable interrupt and then kick the work queue. In the work queue handler, actual sequence is a bit complicated because we have to handle not only normal receiving packet case, such as a DHCP client case, but also handle connect or disconnect case. In these cases, it needs to check if the CID connection ID is valid, then stores information from the packet, then push to the packet to the internal queue, and finally enable interrupt again. This screenshot shows a duplicate example. In this example, duplicate command asks to example.com to obtain tuple-level information by HTTP. Actually, index.html is stored to storage, and you can check the file with cat command in this screenshot. This is a detailed sequence for each network-related system call. In this slide, socket system call is removed because it's already almost same as DHCP client case. With TCP, connect and read system calls are used. In connect system call, it calls I/O control to start TCP client and obtain a new CID. In read system call, so finally receive from request is called, and then call I/O control, so which is similar to UDP case. However, because it's TCP, so packet data will be copied up to the specified length. And if a packet still exists for the CID, then notify userland. This figure shows bulk mode in TCP. So similar to UDP bulk packet, it starts with escape sequence, but it has character Z to show it's TCP. And in TCP bulk mode, there is no IP address and port. In TCP, we have to handle flow control in the driver to avoid out of memory, so when receiving a large data. As I explained, received packets are handled in work queue handler and pushed to internal packet queue, and then notify user. In case of the wget command, wget application stores receive data to microSD. However, writing data speed might not be fast, so the internal packet queue might be very large if we do not implement the flow control. So my approach here is very simple. So when received a new packet, just check the total bulk packet size in the queue, and then the size exceeds the threshold. Then driver continue to disable interrupt until the total size is less than the threshold. Next example is Telnet daemon, which uses TCP server socket. To run the Telnet daemon, so first it checks its IP address by ifconfig and start Telnet D with ampersand. So on PC, run Telnet client with server IP address. After logging in, you can check machine name with uname command. Also, you can check task list with ps command as shown in this screenshot. As I said, Telnet daemon is a TCP server. New network-related system calls, such as bind, listen, and accept, must be handled. As you can imagine, if application calls bind system call, so finally a bind request is called, and then call IO control to create a TCP server in the Wi-Fi module. In listen system call, listen request is eventually called, but there is no listen command for the Wi-Fi module, so do nothing here. In accept system calls, finally accept request is called on the daemon, and then call IO control to accept incoming connection. So finally, I'm going to show you demo videos. In this demo video, so PC and Wi-Fi access point and expressions with GS2200M are used. So demo scenario is like this. So run GS2200M daemon to connect the Wi-Fi access point, then run Telnet and web server and NX player, which is used for audio streaming, and wget, and finally run downloaded L5 application. So first we run pipcom to our own event to connect to the NuttX. So you can see NuttX 9.1.0 is running. Also you can see expressions. So you can check task list with PS and free and connect to Wi-Fi access point with daemon and get IP address with renew command and check IP address with ifconfig and also check the current time, but it's incorrect. So run ntpc start to obtain new the correct IP correct time. Yes, time is correct now. So then try to access web server and Telnet D. But no servers are running expressions, so it's okay to unable to connect. So Telnet, its connection refuse is also okay. So run Telnet D and web server on NuttX. And try to access with Firefox. Yeah, we can see web server is running and try to connect. Yeah, actually Telnet is running, and you can check the PS and free via Telnet client, and then you run NX player, and before that we need to adjust volume, and then start HTTP audio streaming. This is a PCM audio streaming. So now you can listen to music and run PSN free and you can also see network traffic. And there is no checks file is under MATSD0. So next double get to example.com. So check with Firefox. So there's index.html like this. So next download the JPEG file. From PC with wget command. So you can check with Firefox and you can see a SpreadSense JPEG file. Then try to run Hello app, but there is no Hello app installed on SpreadSense, and there is no file under the bin. So then download Hello app with wget command from PC and run Hello app again. And you can see a Hello World again. Then pause the streaming. So audio streaming stopped and then resume again. So you can see network traffic is changing. So finally go back to previous page and refresh and see a JPEG file again. So that's all. So thanks for watching. It might be too technical, but you can understand so what is going on inside the Wi-Fi driver. So now all source code is available at the Apache NuttX Git repository. So if you are interested in this session, please try SpreadSense with the Wi-Fi module. Also, if you have any questions or comments, please let me know. So thanks.
Okay, thank you, Masayuki.
Thanks for playback my pre-recorded video.
Nice presentation, very good. Thank you very much, Masayuki. Now we have the Q&A section. Let's see what questions we have here.
I can see they are discussing the driver implementation, and yeah, some guys are introducing your this YouTube channel.
Yes, I saw it. Thank you, guys. Yes, this channel we have some video tutorials explaining how to get started to NuttX. So
Yeah, I
this,
think so. Alan's video is very useful for to run NuttX for the first time. Yeah.
yeah, they are very basic, uh, very easy to use. So and also it use a low cost board, so we don't need to spend too much money initially, but after you get the basic functionalities working, you can go to a more powerful board like the Sony S Presence or any other.
Yeah.
Yeah.
And
So
I think there is so many driver code out there in NuttX Git repository. So you can refer existing driver source code as well
mhm.
to develop your driver.
Yeah, we have a
So,
question from Mr.
yes.
Gregor Nutt.
Thanks for Greg. Your question is so performance degradation, and I think yeah, actually we have to parse AT command. So this might be perhaps there is a overhead. So I think, but not compared to a full Mac device, but in this with this hardware, there is a SPI speed is much more the bottleneck. Actually, as I said, SPI clock speed is around 10 megahertz, and yeah, that's a big bottleneck for this board.
Yeah.
Yeah.
And apart from the speed, that is not an issue in your board, but could be an issue in other board. Do you see some other issue using the user SOC, or it is
Mhm.
so useful as the native Wi-Fi driver?
Yeah, actually, uh, maybe there is a performance uh, overhead. So when receiving a packet, so sending a packet is not so a little overhead, I think, but receiving is much more overhead. For example, after so receiving a packet from SPI, so via SPI, then this packet must be copied to user land, so via USRSOCK driver framework. And so this is a little overhead compared to Mac driver, I think. And also, user SOC is running inside so daemons context. So in my understanding, so this is also maybe not a bottleneck, but maybe uh, uh, so architecture is different
Yeah.
compared to existing full Mac driver case, I think. So context switch is different. Yeah, when using
Okay.
a user socket driver
Yeah.
framework. Yeah.
Yeah. Yeah, I think user stock is a good option when you don't have SDIO interface that supports some Wi-Fi drivers supported by NuttX, and it's a it's a good alternative. And if I am not wrong, it was is contribution from the Houchan
Mhm.
company, correct?
Yeah.
Yeah, the Houchan is a Finland is a company from the Finland that was many people that came from Nokia. So
Mhm. Yeah.
it's very interesting. But uh, uh, I think we don't have anyone from the Houchan participating here. I don't know.
Okay.
Yeah, but
Mhm.
they are not.
Mhm.
Okay, guys. Let's see.
I can
We
see
have
one more questions regarding the connection limits. So 16 connection limit. Yes, that's correct because this is a hardware. So Terit GS 20 100. So driver modules limitation. It's not a user sock or nor so NuttX limitation. So on NuttX, we can configure as a maximum connection. But in this case, this limitation is from actual so Wi-Fi driver, so hardware module.
yeah, okay.
Copy circuit implement. Spaces to delay duration. Hmm.
So delay.
I can, sorry. I know the Ozaki-san. Yeah, actually, so copy circuit implemented in this process. I'm not sure how the process has such a circuit, but yeah, just over there. Actually, it's not delay. I'm not sure what he want to say actually, but um, in my understanding, there is no such a circuit, and there is not so overhead because just
Mhm.
SPI frame, and of course
Yeah,
we are using DML so with SPI. So such a delay is not observed, I think. This matter of do you see a
And
Yeah, yeah, yeah.
and you just have the overhead to copy to user land to
Yes,
user application.
and
But
yeah, and Luis repeated a question from Mr. Greg, and as I explained, yes, actually there is an overhead. So using AT command because we need to pass so string actually. Um, so what actually command response as well as the bulk mode. Yeah, we need to pass this
yeah,
command and data string.
yeah, there is no zero copy alternative, I suppose. Okay, so if one,
I think this first has to make a circuit
yeah,
copy instead of a
let's,
software copy. Okay. Yeah, but perhaps instead of software copy, so what he wants to say is, of course, we can use maybe memory to memory DMA copy. Yeah, but
yeah,
in
to
this
improve.
case, we are not using such a DMA, but
Mhm.
it will be we can use such a memory to memory copy so with DMA. I think in my understanding, presence DMA controller has such a feature.
Okay, so if someone have other questions, we have, I think we have one more
What is
here.
the kind of
Can
projects
you
you were
let
planning
us
to use this in?
because using it?
That's a difficult question, and I cannot answer to. This is a very
Uh,
highly confidential.
eh, yeah, you cannot provide such information here
Yeah.
because it is a public conference, a public
Hmm.
workshop, and it could be an issue for you. We understand
Hmm.
it, and as for Andre as well, this is why I asked him if I could
Hmm.
supply some information. And so I think that's it
Automated has
for
and
this
sorry,
presentation
I
here.
cannot know about so Atomero related questions. I
Uh,
cannot say anything about that Atomero.
uh, uh, yeah, at Mel, the AVR is
Mm-hmm.
supported, but it doesn't have enough memory. I think there's only one or two AVR,
Mm-hmm.
Atmel AVR that has enough memory to run NuttX because the kernel is small. But imagine after you put the kernel in the real world, you will want to put many more features, and you will not have too much memory at the end of the day. So it's better to use a microcontroller uh, with 16 kilobytes of RAM or more.
Mm-hmm.
Otherwise, you are limited uh, to what you can put inside your microcontroller. So
And one more question so regarding encryption. So are you talking about TLS or SSL?
I think so. I think
In that case, so we can use so embed TLS, for example, so on top of TCP stack. Yeah,
uh,
on top of user socket TCP stack. Yeah.
yeah. And I saw the email from the your company guy suggesting to submit the embedded TLS to
Mhm.
mainline some time ago.
Yeah.
Okay, guys, we have less than 20 minutes.
Hmm.
So uh, I think that is all for the question. If people still have more questions to ask Masayuki, please go to the forum. We have the forum link in the video description. So uh,
Yes, please send me a question, any questions.
yeah, and there you can interact more easily with you.
Yeah, and
Yeah.
I want to answer as long as I can.
Oh, great. Thank you very much, Masayuki. It was a very good, very interesting presentation, and I'm sure it will be useful for many people.
Oh, I have a question. One more question regarding SDIO. I think SDIO is might be possible, but so we need to change the internal formula. So inside GS 2200M modules, we need to change the formula. So inside the module.
Okay.
Yeah, of course SDIO is of course SDIO is faster than SPI in many cases.
Yeah. Okay.
Yep.
So, guys, thank you very much
Thank you.
for your time. As you know, it's very late now in Japan.
Hey, it's
Uh,
okay. And tomorrow, so my colleague, so Sugino-san, will also talk about NuttX, so with last language. So please watch, attend his session. Yeah,
yes,
please.
his presentation will be very interesting. It's about Rust language, using Rust language
Mhm.
in NuttX. I'm sure it will be a very very good
And
presentation.
also, so Arin will talk about so presence, um, how he ported presence related code to NuttX upstream, maybe a few hours later. So today's
Nice.
session. Yeah.
Okay. Thank you again.
Yep.
And so let's to move on.